Alrighty, so another example of Dijkstra's algorithm. So I'll read through it. The weights of the graph below show the distances between the towns in kilometres. Use Dijkstra's algorithm to find the shortest path between St Andrews, which is here, and Tulangi, which is over here. Now we've got the names of the vertices there, which are towns, but we've also got some vertex letters there to denote those. So we want to find the shortest path. So the first thing we are going to do is we have our starting row vertex, which is S. All right, so we're going to draw up our table, which is S. That's going to be our starting row. And then we're going to fill in all our other vertices as our columns. You can just work left to right. So we've got K, Y. That's a K, Y, T, and H. Now, what I actually like to do is, since T is our finishing vertex, I'm going to swap these two around just so that we have T finishing last, like that. Next, what we need to do is now we're going to complete our first row. So we look at the connections from S to K. All right, S to K is here. It has a weight of 13. S to Y has a weight of 15, so we put that one in there. And S to H has a weight of, well, we can't get from S to H directly. Other vertexes we have to go via, so we're going to put a cross in there like that. What about S to T? No, we need to go via other vertexes, so we're also going to put a cross in. So we've completed the first row. Now to get our second row, what we need to do is we need to put a box around the smallest number or weight within that row. Now we can see that that's 13, so we're going to put a box around 13. And that is in column K. So we're going to bring the K down to our next row and bring down the box number, like so. All right, so that's the first couple of steps. Now we need to complete this until we have a box around our end column vertex, which is T. So now we complete again. So K to Y. K to Y has a value of 26. Cool. So we take 26 and we add it on to the box number that we brought down, which was 13, and we actually get 39. All right. We don't just put 39 in there. We put at the value above it. We look at the value above it. Now it is 15. It's less than 39, so we're actually going to copy in 15. All right, 15 is going to go in here. Even though we had 39, we always bring down the smallest number. All right, K to H. K to H is, we don't have a direct connection. Now we look above, is there a number? No, so we're going to put our X in. K to T, there is a connection here, which is 15. So we take 15 plus our 13, which was over here. So we're looking at that K for our row, plus 13 equals, what do we get? 28. Look at the number above it. There's no number there, so 28 is going to take the value just there. So I'll rub that out, put our 28 in, and then we look again. We look for the smallest unboxed number. We've got 15 and 28. 15 smaller, we put a box around it. It is in row Y, so we bring Y down to our column and bring down our box numbers. And repeat. Y to H is a connection. Yep, 14 plus the box number for row Y, which is 15. So there we get 29. Look above. There's no number there, so we're going to put 29 in there as we've got nothing else to bring down. So that becomes 29. And then we go Y to T. Is there a connection? Yes. There is. It's 23. So we go 23 plus our value for Y, which was 15, which is going to give us 38. All right, 38, look at the number above it. It's 28. It's smaller than 38, so we are actually going to bring our 28 down and put that just there. Cool. For that row now, we put a box around the smallest number, which is 28. And we've actually completed all the rows we need to do. Because we're trying to get to T, and T for the column now has a box around it at 28, we actually stop there now and move on to our last step, which is backtracking. So backtracking can be a little bit tricky, but we're going to backtrack. That's what its name is. So we're going to start at the end. So we start at 28. at our t in the y row. And we start there, we've got the number 28. So we're going to draw a vertical line up as far as we can to the last number that's 28. There it is. We don't go up to the cross because that's not a 28, we stop it there. Then we look at the row that 28's in. It's in row K, so we're going to draw a horizontal line across till we're in column K. Bring it all the way across, we're in column K. Column K is a 13, we're going to draw all the way up to the last 13, and then we stop there and we finish at S. Now, last part of the backtracking is we now need to put all the rows that have a vertical line and then add on the end vertex. So, does S have a horizontal line? Yes, it does, just there. We've got a horizontal line here for K, and then we've got a horizontal, no, that's our last horizontal line. And then we include our last finishing vertex, which is T. So we go S, K, finish at T, and its length is the last box that we finish in for T. So it has a length of 28 kilometres. Few steps, have a look at the further examples. This is the path, SKT, length is 28 kilometres.